Under the Mobile Serve offer, this video is a piece of the on-the-job training curriculum for open gear lubrication inspection. The goal is to enable you to convert customer needs and opportunities around these activities into improvements in safety, environmental impacts, and productivity. Typically, these inspections are used for mills and kilns in mining, mineral processing, and cement plants, but they may also be applicable in other industries. The video is the first part of the OJT curriculum. After viewing it, you should job shadow a competent person completing an open gear inspection. Then have the competent person observe and coach you as you complete an inspection. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. Barry, a field engineer with ExxonMobil, has been working with this existing customer on a number of mobile planned engineering service projects. Mark, his contact at the plant, tells Barry that he'd like them to focus on some specific areas of their agreed PES objectives. Both Mark and Barry believe that an open gear lubrication inspection can aid in understanding the root cause of some problems Mark has seen. Barry works with Mark to understand the impacts of any lubrication problems, so he can later use this information to show how his findings and recommendations can reduce these impacts and produce value for the customer. For some customers, Barry performs routine open gear lubrication inspections to proactively look for improvement opportunities or to detect abnormal operating conditions. To help bring solutions and value to his customer, Barry must be an excellent detective and must collect the data needed to help determine the root cause of any open gear problems. Before meeting Mark again for the inspection, Barry gathered background information, lubricant consumption, downtime cost, reliability history, service and repair history, and the cost and frequency of gear cleaning. Barry also reviewed previous used oil analysis for oil condition and signs of wear and contamination. This is for the mill's bearing and enclosed gear lube systems. Then, just before his site visit, Barry went over his safety preparations like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also read through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including personal protective equipment, PPE. He prepared and reviewed his toolkit, including clipboard or tablet PC or iPad, infrared temperature gun, flashlight and strobe light, sample thief, bottles and labels, digital camera, rags, and owner and maintenance manuals for the central lube system. In this inspection, the mill uses a single-line parallel injector system, but other mills may use other types, like dual-line parallel systems. It is important that Barry understands how each system type works. On the morning of the site visit, Barry and Mark first review their goals for the visit.
We're ready to actually go out and do the test today. First thing I'd like to do is go over our job safety analysis with you.
Barry goes over his safety plan, and together they review the personal protective equipment they'll need: hard hat, safety glasses, hearing protection, cut-resistant gloves, visibility vest, and safety shoes.
Is there anything else additional that you know for PPE that we would need out there?
We just have to make sure our safety shoes are metatarsal.
Okay, good.
In this video, Barry is performing a dynamic inspection with the mill running. In some cases, inspections take place with the equipment shut down, for instance, to take wear measurements. In such cases, Barry would have the equipment locked out to control all potential energy. Those metatarsal safety shoes protect Barry as he walks up these stairs, where he maintains three-point contact. Hoses in the walkway catch his attention, so he sets them aside. One of the first items on Barry's SOP, the standard operating procedure, is to inspect the input compressed air to the central lube system. He wants to ensure that the proper pressure is being applied, that the customer is using air purification, and that there is not excessive water in the air. Barry has his partner manually cycle the air system so he can check that the pump cycles on and off properly, reaching appropriate pressures. He checks if proper transfer containers are used and labeled correctly. He inspects the keg or drum for follower plate, dust cover, and evidence of contamination. and he checks for proper use of drum heaters. He performs a thorough external examination of the equipment, looking for signs of contamination, overheating, corrosion, oil leaks, grease accumulation, and damage. Before opening the cover to the open gear, Barry cleans the surrounding area, making sure not to contaminate the gear mesh area. He also follows the customer safety procedures for opening and inspecting through the cover. In addition, Barry uses his Safe Performance Self-Assessment, SPSA, to help ensure that he identifies the safety risks, analyzes them, and takes any needed mitigating actions. This also helps ensure that Barry has his head in the safety mode. Barry uses his infrared instrument to take temperatures of the open gear sets while the mill is running. He takes the temperature along the face width, that is, pitch line, of the pinion tooth just as it's coming out of the mesh. This is called the working face. He is checking for proper lubrication and gear alignment, as indicated by even temperatures across the gear teeth, and by temperatures consistent with previous inspections under similar load conditions. Barry sets the strobe light to the same speed that the gear is running, then looks for proper lubrication. Take care. What you see can be deceiving. Under the strobe light, those gear teeth appear stopped, but they are moving and extremely dangerous. So never break the plane of the pinion guard when the door is open. Done properly, this is not a dangerous task, but if done incorrectly, it could have devastating results. Barry examines the loaded face of the pinion teeth. He looks for signs of over-lubrication, that is, lubricant buildup in the root zones, fling off or lube buildup on teeth, or excess lube on guards. The strobe light helps him to detect misalignment. Less contact along the gear meshing and increased wear are signs of misalignment, and more wear concentrated towards one side of the gear would indicate potential misalignment. Barry needs to check that the air pressure has been properly set to spray the gear lubricant to provide proper lubrication. Too low of air pressure will result in splattering, while too high will tend to blow the lubricant off the gear. Barry checks the pressure gauge to ensure it is set properly, allowing all the injectors to fire before the pressure switch activates and stops the lubrication cycle. He checks the injectors, seeing that all of them fire properly when a coworker manually cycles the system. In addition, he checks to see that the spray pattern is appropriate. He also evaluates the injectors and feed lines to look for signs of leakage, or if the injectors are bypassing once they have fired. He also checks to see that each injector has reset for the next lubrication cycle. Barry inspects the lubrication timer box. He checks to make sure the timer is set at the proper time interval. This is where he or his partner will manually fire the lube system to ensure proper operation. By conducting the inspection on the gears and lubrication system, Barry evaluates the quantity of lubricant, the system reliability, and how well the gears are being lubricated. He uses this information to determine if there are opportunities to optimize the lubricant quantity or distribution. The optimization may come through safely reducing lubricant consumption, which would lead to reduced lubrication costs, or through increasing lubricant consumption or correcting lubricant flow and/or distribution to minimize gear wear. Barry would collaborate with the customer before making any adjustments. In many cases, the customer will want to make the actual adjustments. Typically, Barry starts with the mill equipment builder lubrication recommendations, then verifies them with calculations using the MobileServe engineering toolkit and/or AGMA guidelines. This provides a good starting point. Barry may also recommend conducting another inspection with the mill being down, where he and the customer evaluate the gears for wear and proper alignment, as well as for proper lubricant quantity and distribution. If an asphaltic or grease lubricant were being used, he would check for excessive gear teeth root lubricant buildup. He may use a vernier and molds to record wear measurements, that evaluate wear patterns to help determine the root cause of the observed wear. As ever, he leverages equipment builder references to help him conduct these evaluations. To check for proper lubrication spray distribution, he may use cardboard as the lube system operates. In some cases, Barry may want to consult the mill equipment builder to help evaluate any abnormal conditions, to help him arrive at the optimal recommendations for the customer. Barry uses his infrared gun to check temperatures on the other critical equipment components on this mill, such as the pinion support bearings. He also looks for other areas of opportunity, like lubricant leakage and contamination control. He will also check the equipment vibration, typically by working with the customer's vibration analysis department, or by using a simple vibration probe, looking at trending versus previous inspections. Barry notices how the plant has tried to deal with high open gear lube application rates by putting in guide rails and this barrel to catch runoff. By optimizing the lubrication, he can potentially reduce this consumption. After his open gear inspection, Barry meets again with Mark to explain his preliminary findings. He tells Mark that he will develop those findings and combine them with measurements and photos to prepare an engineering service report for Mark and his supervisors. He must take in all the facts and sequence of events to determine potential root causes of any problems he finds. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce the best value.
That's impressive. Things are looking great.
Okay. Well, thanks. I'll check in with you after we get done, probably about lunchtime.
Barry can demonstrate that his findings and recommendations produce an excellent return on investment and value to his customer. Barry and his sales advisor will use this report to promote our value to other key contacts at this customer. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. By using the standard operating procedure as a guide, as well as the other tools described, Barry can consistently conduct these studies and deliver outstanding value to his customer.